All right, we're back at the notes. We are going to do an example. Tony raises Siberian Husky sled dogs at her kennel. From years of data, she knows that the weights of adult male dogs are normally distributed with a mean of 52.5 pounds and a standard deviation of 2.4 pounds. So let's just label those right now. This is going to be mu, and this is sigma. Okay. Sketch a graph to show the distribution of weights of adult male dogs. So I'm going to tell you right now that you and I don't know enough about stats to do an accurate graph. Okay, you saw how the shape of the graph changes according to how big the standard deviation is and what the mean is and yada, yada, yada. And I have no idea what the graph of this would look like. I do know that it's going to have, and leave some space here because we've got writing to put in after this. So I know there's going to be a straight line. Ha ha, good line. And it's going to look sort of like a bell, kind of like this, symmetrical about a point, and that the middle of this is going to be our mean, so mu, which is 52.5, right? And then going up, it's going to be divided into 3 pieces that are the same distance apart on the x-axis, like that, where this is going to be, I'm not sure I can even write this small, it's going to be mu plus sigma, this is mu plus 2 sigma, and this is mu plus 3 sigma. Whoops, not much of a sigma. There we go. And then the same thing on the other side. 1, 2, 3. That was not very symmetrical, was it? But that's okay. This is just a sketch, okay? This is mu minus sigma, mu minus 2 sigma, and this one is mu minus 3 sigma. Okay, so that's minus 1 standard deviation, 2 standard deviations, and 3 standard deviations. And then we're going to put some numbers in here. Okay, so we know that mu is 52.5. Mu plus, whoops, that's not a mu. Mu plus sigma is going to be 52.5 plus 2.4, which is 54.9. So that's going to be this point here is 54.9, or this line rather. And mu plus 2 sigma is 52.5 plus 2 times 2.4, which is 57.3. So that's this one is 57.3. Mu plus 3 sigma is 52.5 plus 3 times 2.4 is 59.7. So that's this one is 59.7. And then we do the same thing going in the other direction. I'm just going to do one. So mu minus sigma is going to be 52.5 minus 2.4, which is 50.1. So that's this one is 50.1 pounds. And then I'm just going to put the numbers in for the others. This is 47.7 and this is 45.3 pounds. Okay. So there's our drawing. There's our sketch showing the distribution of weights of adult male dogs. Now I'm going to suggest that you actually pop over to that Desmos website that we were just at and put these numbers in. Put in the 52.5 pounds as the mean and the standard deviation of 2.4 and see what the shape of the graph actually is. It could be more spread out. It could be more up and down. I don't even know. I would flip over, but I'd have to stop the video again, and I don't want to do that. Okay, what percent of adult male dogs at Tony's kennel would you expect to have a weight between 47.7 pounds and 54.9 pounds? So 47.7 pounds is here, and 54.9 pounds is here. I'm pointing up at the graph up there. And there were some numbers we didn't put up here, but we do know that there are 34% of the dogs in here and 34% approximately in here, and approximately 13.5 in here, and 13.5 in here, and 2.35 and 2.35, right? So between this line and this line, we would have 13.5 plus 34 plus 34 is 81.5. So we would expect that 81.5% of the dogs weigh between 47.7 pounds and 54.9 pounds. Isn't that cool? I think it's cool. Okay, what percent of adult male dogs would you expect to weigh between 50.1 pounds and 59.7 pounds? Well, we're just going to do the same thing. So